So the next topic what we are going to discuss in this class, that is total station, right? So in the previous class we discussed about some modern equipment which are going to be used in the surveying, right? So in that we discussed about some instruments which are going to work based on the principle of electromagnetism, that is electronic distance measurement equipment. Okay, so in the previous class we are going to see the most versatile and very useful instruments called total station, right? So let us see about total station. So a total station is a electronic or optical instrument, right? So used in the modern surveying and building construction that use electronic transit theodolite. Okay, so here it is a type of theodolite, right? So it is going to works on the electronically, right? So and in conjunction with the electronic distance measurement. Okay, so what we are going to do here, okay, we are going to combine the theodolite as well as the EDM, electronic distance measurement equipment. So with this both we are going to, okay, so combine now, so then we are going to get the total station. With help of this, with the help of theodolite we can find out the angles, vertical angles as well as the horizontal angles. Then with the help of the EDM we are going to know the horizontal distance, right? So in addition to that we are going to know even elevation points also, right? So now all values we are going to know with the help of this, that's why it is named it, okay? So total station, right? So it is also integrated with the microprocessor, right? So like a computer, here we have a microprocessor, electronic data collector, and that means the memory, right? So the thing, whatever you did in the field work is going to store in the equipment, then on the storage system. Okay, so you have a microprocessor to analyze the data, then electronic data collector, right? So once you measure the data, it is going to collect and finally it is going to store in the memory, right? Next, the instrument is used to measure sloping distance of object to the instrument, right? So horizontal angles and vertical angles. Okay, so this can be measured for the distance, horizontal angles, then vertical angles. Then this microprocessor unit enables computation of data collected and further calculate the horizontal distance, coordinates of the point, and reduced level of the point, right? So with the help of this microprocessor, okay, whatever data you collected now, so that is going to be processed, right? So that is going to be processed and finally you are going to get the RLs, right? Reduced levels. Then we are going to get the coordinates and we are going to get the horizontal distance exactly from instrument to the whatever point you take for the measurement, right? So finally, total station is a combination of transit theodolite, electronic transit theodolite, along with the electronic distance measurement, right? So here we are going to have the microprocessor, data collecting device, as well as the storage system, where the microprocessor is going to get the data from the storage and as well as the data collection system, and it is going to process and it is going to give the final values, right? So like reduced levels, horizontal distance, and as well as the vertical and horizontal angles. All that maximum of surveying work we are going to get from this instrument, right? So now data collected from the total station can be downloaded into the computer or laptop for further passing information, right? So you no need to note down anything in the field, right? So whatever surveying you did on the field, right, it is going to store in that equipment. So whenever you go to the office, then the total station is going to connect with the computer or laptop, so that we can retrieve the data from the total station to the laptop, right? So that kind of facility is there. Next, total stations are mainly used by land surveyor and civil engineers either to record features in a topographic surveying or to set out the feature, right? So first thing is surveying. We are going to collect the data from the field, and the next step is we are going to plot, right? We are going to set the whatever plan we have to the ground, right? So that two things will be there, but total station can be used for both purposes. One is collecting data and second for setting out of the features also, right? So next, they are also be used by archaeologists to record excavations and by police for crime scene investigations, okay, private accident reconstructionists and insurance companies to take measurements of, right, scenes, right? So this can be also be used for archaeology, and it can be used by police for crime purpose, and then for insurance of the insurance company is also going to see the what the thing happened there, right? So for those kind of verification also this total station can be used, right? So the fundamental measurements, right? So with this total station, what kind of fundamental measurements you are going to take now? So when aimed at an appropriate target, a total station can measure 3 parameters, right? So here simply we will have a what is called instrument at one particular point, and wherever you want to know the reading, no, so there you have to put a prism, right? We have put a prism from this electric waves will go there and will come back to the total station. Then we will get the distance, then we will get the angle, then we will get the reducer levels. Everything we will get with this arrangement, right? So please remember we need a total station equipment along with the prism setup here. Okay, so when the rotation of the instrument's optical axis from the instrument north in the horizontal plane, right? That is horizontal angle. So we are going to know the horizontal angle. So horizontal angle will be there from the rotation of the instrument's optical axis from the instrument north in a horizontal plane. If you are moving in horizontal plane like this, so finally you are going to get horizontal angle. If you are rotating in vertical plane now, so you are going to get the vertical angle. Okay, the inclination of the optical axis from the local vertical, right? So from the local vertical, whatever inclination is there, that we are going to get, that is called vertical angle. Okay, next, the distance between the instrument and the target, that is we are going to get the slope distance, we are going to get the vertical angle, and we are going to get the horizontal angle. Okay, let us see in a pictorial manner, right? So at all the numbers that may be provided by the total station are derived from these 3 fundamental measurements. Okay, one is vertical angle, another one is horizontal angle, and third one is the slope distance. Okay, from there we are going to get the horizontal angles, vertical angles, and the slope distances. Right now, here you can see. So here you are kept your instrument, right? So this is the vertical plane, right? That is called from. This is the horizontal plane, and this is the direction with where you are going to set up the instrument to the 0, that is called instrument north, right? So based on instrument north, whenever you turn the instrument in a vertical plane, so that we are going to get the horizontal angle value, right? So whenever your instrument is rotated in the vertical plane, no, so then we are going to get the, right, so vertical angle. Okay, this is the vertical angle. Okay, so vertical angle you are going to get. Okay, then next, this is the, if you are sighted in the line of sight, we are going to get the slope distance, right? So with this you can see here with the instrument north. Okay, when you rotated around with the vertical axis, no, so we are going to get horizontal angle. So with the horizontal you are moving up and down row. Okay, we are going to get the vertical angles. Then whatever the distance you are going to measure, that may be the slope distance, right? So now components of a total station. What are the different components? Okay, it will have, right? So let us see one by one. Already we know that it is going to have the distance measuring instrument, that is electronic distance measurement (EDM), and angle measuring instrument, that is theodolite, and simple microprocessor, right? So the components used in this total station surveying are follows. The first one is tripod. We need to have a tripod, that is to hold the total station instrument, that is going to hold the total station. Next, an electronic notebook, okay, used to record and calculate, even manipulate the field data, right? So inside the instrument we will have a notebook. That means whatever values you are going to measure, no, so it is going to record itself. Okay, so for that you have a notebook. Then prism and the prism pole, right? So for this, I already told that. So along with the total station, we need one more thing called prism and prism pole, right? So prism pole is going to give the support to the prism. So prism will be kept wherever you want to take reading. You have to place it over that point. So from the instrument you have to sight that prism. So if you go for measure, no, so then light waves will go there and will come back, right? so that it is going to calculate your horizontal angle, vertical angle, as well as the distances based on that thing, right? So it long 2 kilometers and up to 6 to 7 kilometers can be measured with the triple prism, right? So with our prism we are going to see up to 6 to 7 kilometers, right? So we have another thing, battery for the power source. It is a power source. So finally what we are having, we will have a tripod, okay? So we have instrument like notebook, then notebook means the storage things, right? Next prism and as well as the battery. So these are the some basic fundamental things which is required for a total station, right? So now we can see here, okay? So the first thing is this is the total station instrument, right? This is the total station instrument where the first thing is handle. This is the handle to hold the instrument in the field, okay? This is the telescope for rough target of prism, right? So this is actually telescope, okay, to see the to see or to emit the light and to receive as well as to receive the what is called backlight, okay. So that's why here they gave some warning, don't see into the this end of the telescope, right? So this here we have a screws to control the horizontal movement, right? Even vertical movement of the telescope. Then we have a touch screen, what is called keypad here to enter the data or to enter the points, and we have a display over here, right? So electronic display. So both sides it will be there. Then this is the screws to control the horizontal rotation of that particular total station. So there we have a main screw as well as the tangent screw for slow motion. Then we have a tri-bar here. So where we have the bubble, right? So bubble for leveling and for screws also there, level screws there for leveling the instrument. One side of this we are going to attach the battery, right? So there are the some of the fundamental parts. So in the next topic we are going to see that now this instrument is taken from the what is called box, and we are going to keep it over the tripod. You can see here. So we have an adjustable tripod here. If you want, you can adjust with the help of these screws. First we have to firmly fix into the ground, right? You have to press into the ground so that so low winds, even high winds cannot make total station to fall, right? So you have to take care of all these. Okay, since it is not a cheap instrument, it is going to cost around 1 lakh, 2 lakh, 3 lakh based on features, right? So we have to going to keep it over and we need to screw it. Okay, so this is the what is called tripod and as well as the instrument. Then coming to the prism, right? So this light is going to fall on this prism. It will come back to the again to the instrument. For this we need to have this kind of prism, right? So this prism is going to mount it over the prism stand like this. Okay, this is the prism rod. So whatever height you want to know, you can adjust to this. Okay, so there are the fundamental things you require for the total station survey, right? So next, parts of the total station. Okay, so here we can see that is system is there. This is handle, right? So already told. So here we can have the even to get the what is called network, right? So we have electronic leveling system, then display, keyboard, right? So you can see the leveling screws, and we have screws and they are to control the horizontal movement, right? So let us see one by one what are the different parts are there. First thing we have the handle, okay, that we saw at the top. Next, handle screw, right? So to have all this we need that. Next, data input and output terminal, where we are going to connect, like our phone, right? Mobile, right? So smart mobile phone now. So you can connect with the data cable to the system or any laptop. You are going to get the data from the phone, or you can transfer data from computer to the phone like that now. So for that we have a data input and output terminal. Sorry, it is a screen. Basic is this is a keyboard and display, no? So it is there. We have a display. Okay. You have the display over there, right? So display and keyboard, those are the data input as well as the output terminals, right? So input is the keyboard, output is the screen, wherever you are going to see the reading. Then we have the instrument height mark, right? So it is have what is the height. Okay. So next battery cover we are going to have. Then operational panel, right? So where you are going to operate like keyboard. Then tri-bars clamp. Okay, at the bottom it will be there to clamp to the what is called the tripod. Then you have base plate there near to the tripods. Then leveling foot screws already we saw 3 number will be there to make level to the total station. Then you have circular level adjusting screws. Circular level means rotation. Okay. Next, circular level will be there. Okay. So it is there over the tri bands, right? Where you can do the what is called leveling, right? So accurately. Then you have a display. It is there to display the values. Then you have objective lens. Then you have a tubular compass slot. Okay. So where you have a compass, then we can keep it. Next, optical plummet focusing ring, right? So here we have some advantage that, right? So at the side, right? At the side we are going to have the optical plummet, right? So okay. So with the help of this we can sight, right? So you can sight or you can adjust with that. Here we will get a picture, right? So that the instrument is going to what is called make it to level, right? And you can see whether the instrument is positioned exactly over or not. So those kind of things we will do with the help of this, right? So that is optical plummet. Then optical plummet eyepiece will be there. Okay, focusing ring, everything is there. Then horizontal clamp and fine motion screw, right? If you want to rotate like this. Then external power source connector. Okay, if you want an external source other than battery, you have a connector. That plate level and adjusting screws we have. Vertical clamp and fine motion, as well as horizontal we will have a similar kind of thing, that is vertical clamp. Then we have the telescopic eyepiece, then telescopic focusing ring, okay, peep sight, that is instrument center mark. So these are the different parts or things we can see on the total station, right? So now basic steps involved in the total station surveying. What is the basic step? We need to get the instrument from the box, get out of the box, and you need to open the tripod, you need to fix it to the tripod, right? So then you can start the sight towards the what is your prism, right? So that you are going to put the measure, then automatically you will get the values. This is the main procedure. Let us see what is that. Step 1, setting up the instrument along with the tripod. We are going to set up the instrument onto the tripod. Next, leveling of the instrument approximately with the help of the bullseye bubble, right? So bullseye bubble is there near to the tri-bands. We are going to make it approximately level, and then verifying level electronically. So we have electrical plummet now. So with the help of that on the screen we are going to get whether it is got level or not. Okay. Next, step 3, adjustment of optical focus and image. Okay, we need to adjust the what is called telescope so that the prism is visible clearly. Then record all the measurements. Okay. Then data processing. Okay, so you are going to do the processing of this data. Next, advantages of the total station. Okay, what are the different advantages we can see now? Quick setup of the instrument on the tripod by utilizing the laser plummet. So with the help of this, so you can set exactly over the point and you can easily make it level, right? So programmed with the onboard area computation for computing the area of the field. So you don't need to use any computer, you don't need to use any calculator. Okay, so directly it is going to give your area calculations. Then it supports all local languages. Okay, so it shows the graphical view of lands and plots. Okay, so even you can see on the display what is the view of that particular land or plot. Okay, so it is having no recording and writing errors, right? So whatever value measured now, same things will be recorded correctly. Then it gives more accurate measurement than any other conventional surveying instrument, right? So next, data can be saved and transferred to a personal computer or laptop. You can save the data. Okay, so it is an integrated database. Okay, next, computerization of old maps. Okay, you can do the old web measurements. You can make it computerization all in one and multitasking instruments from the surveying to the GIS creation by using the appropriate software. So, okay, so by using any software we are going to plot the even plans and maps also, right? So it is having faster work and saves time quick finishing of the work. Okay, so it can give very fast measurement. Okay, so that our time will be reduced. Okay, next applications of the totalization, right? So where you are going to use this totalization now. So the first thing is general purposes of angle and distance measurement. Okay, so we are having the angle and distance measurement, plotting the contours, right? So next, illustration of details of maps, carrying out the controlled surveys, archaeological use. Okay, police, I already told that used in the missing pillars also we are going to do. Remote distance measurement also you can do. Missing line measurement, MLM we are going to do, and remove elevation measurements, right? So these kind of all surveys we are going to use this totalization mainly. Okay. So next, uses of totalization. Okay. So it is going to use in the mines to find out the missing points and any other things. Cadastral survey for the land measurements. Okay. And for engineering surveys like road, canal, and any construction purpose. Then large scale survey. If you want to go for railway line or highway line, it is going to be useful, and even road, rail, canal, any kind of survey. Okay. Now this is the advanced equipment for the survey. Okay. So the learning of this instrument also is very much needed. Okay. So now I am going to summarize today's class. Okay. So in the today's class we saw what is the survey totalization, right? Totalization is the combination of transit theodolite, electronic transit theodolite, and as well as the EDM, electronic distance measurement, and it is a theodolite, electronic theodolite, right? So this is used for the all kind of surveys. It is having so many applications since it is having very less work, right? So it will give more accurate values. It is going to collect the data. It is going to store the data, and it is going to give. You can retrieve the data from the totalization into the PC, personal computer, or into the laptop, right? And also we saw different parts of it, right? So mainly it is having a main instrument, then tripod stand, and we have a prism and a prism stand, right? With help of these four things we are going to do the totalization surveying. Okay, so that's all for today. Thank you.